Hello everyone. Today we are going to solve this problem called design circular deck. Okay, so if you are familiar with, I'm going to use Python 3 to solve this problem. And if you are quite familiar with Python 3, you might know there's a module called collections, and in this module, um, there is a class called built-in class called Deque. Okay, so and I really like this kind of problem because um, you know sometimes we will just use the collections, the built-in class to solve some kind of other problems. But this kind of problem really give you uh, an opportunity to learn how to really implement it by yourself. So I really like this kind of problem. Okay, and so okay, in the description, the description says that uh, you have to design this deck, and deck is also known as double-ended queue. So you have to implement the constructor, set the size of the queue to be k, and there are these methods you have to implement. So first one is to insert an item at the front of deck, and that's the second one is to insert an item at the rear of the deck, and there's a function called delete from. You have to delete the item at the front of the deck and delete last delete the item from the rear of the deck, and get from is to get the front item, and get rear is to get the last item, and it's empty and it's full is just to check whether the deck is empty or full. So and there's a note here, but I think uh, the real really important thing here is is this the last one. So please do not use the built-in deck library. So it really makes sense because the goal of this problem is to ask you to implement it, and you use a built-in deck library to implement it. It's quite stupid to do that. Okay, so okay, so first we will start from the constructor. So here I will create a data structure, a list, and the list, because we already know the size of the list, so we will define the list like this, and we also create another instance variable called max size. And the max size is to store the size of the deck, which is k. And okay, and we also need a variable called size, and this is going to track the current size of the deck. Okay, so after that, usually I will start from this. I will start from the easiest one, or I think that it will be needed to be implemented first. So it's empty. It's quite easy. So you just need to check if the current size of the deck is equal to 0, and for the method is full. It's quite similar with similar to is empty. You just have to check if the current size is equals to the max size. Okay, so if the current size is equals to max size, then that means the Deque is full. And okay, so now we are going to implement insert front. So for insert front, one thing you have to pay attention to is before you want to insert something, no matter you want to insert at the front or at the rear, you have to check if the Deque is not full, right? If the Deque is full, then you can't insert anything else into the Deque. Okay. So we want to check if the Deque is not full, then okay. So now there's another problem. We don't know where is the front of the Deque, and we don't know where is the end of the Deque. So we might need to define other variable, and in this case we need a head pointer and a tail pointer, and both of them are starting from 0, index 0. So here we go back to the method insert front, and so now we can actually implement it. So because it is a circular Deque, so we may have to do this. So when you insert an item at the front of the Deque, the pointer should go to the left of the Deque, right? So the pointer should -1, and because it's circular, so we have to mode self max size, all right? And then when the pointer is pointed at the right position, we can actually assign the value to the position. Okay, so do this, and because we insert a new element into the Deque, so the size of the Deque should +1. And when we finish, and return true. If it's not it's full, the Deque is full at the moment, then we have to return false, right? So that means we can insert anything else into the Deque. But there is a tricky thing here, because there is a case that now we might encounter something like this. So for example, if we have the size of the deck now is 4, and we are just starting to inserting new element into this empty deck. Then in this case, the pointer head and tail are pointing to the first element. Okay, and if this is the case, then if we do what we just done here, we will mix the first element, right? Because here we say that okay, if we check the deck is not full, then we will move the head pointer to the previous one, which is the last one in this case, right? And we insert the value here. Okay. But you can see that this will break the whole thing, because if now we are going to insert another element at the tail, then we will insert the tail. We will do the same thing here, right? Like we will move the pointer to the next one, and we insert another value here. And in this case, there will be a empty element between head and tail. So to prevent this situation, we have to check another condition, which is if the deck is empty. So if now the deck is empty, then we don't have to move the pointer before we assign a value, right? We just assign the value to the current position. So we just do this. First, we just assign the value to the current position, and the same thing because we insert a new element in the deck. So the size +1 and return true. Okay. So here we have to change to else if. Okay, so this is the insert front. Okay, so now we are going to insert last. So the process you might be able to imagine that it's quite similar, right? So if self is empty, then self deck value and self the size +1 and return true. And if not self is full, self head, self tail. Okay, self tail. So when you insert a new element at the rear of deck, the tail pointer should move to the right of the deck. So +1 and again mode max size. Okay, and self deque self tell assign value and self.size +1 and return true, else return false. Okay. Okay, now we are going to implement the method delete front. Okay, so just like the case we are inserting the new element, when you want to delete something from the deck, the first thing you have to check is to check if the deck is not empty, right? If it is empty, then it makes no sense to delete anything from the deck. Okay, so first thing we have to check is not empty. Empty. Okay, so if it is not empty, and because we are implement delete from, so we delete the element at the head pointer. If self okay, so just like insert these two insert methods, we in this in delete method we also need to check if it is if the size if the deck size is equal to 1 or not. Okay, so if it is not equal to 1 and self head if it is not equal to 1, so it's not equal to 1, we have to move the pointer and because it is a circular deck, so mode self.max size, and after that we have to -1 size the size has to -1. Okay. So here, if the size is not equal to 1, then we have to move the pointer. So that means if the size is equal to 1, we don't have to move the pointer. So you can think about it just like what I said before. So if the deck size is equal to 1, that means now the head pointer and the tail pointer are pointing to the same element. So in this case, you just have to remove the element, but you don't have to move the pointer, right? Okay, and for delete last is is quite the same as delete from. So if not self dot empty, and self deque self dot fill equals to none, and also we have to check if the size is not equals to 1. If it is not equal to 1, then we have to move the pointer. So -1 and mode self dot max size, and also we have to do size -1 and return true. Okay, and else return false. Okay, and get from. So now we are going to implement get from and get rear. So we just have to return the value, which is pointed by the head pointer. But one thing we have to check is that we have to make sure the deck is not empty. So if it is empty, then we just return -1, and same thing, get rear, we just return self. Okay, so I make a mistake here, so it's actually deck not Q. Okay, and also here we return the element pointed by tail pointer, and we have to check if it is not the deck is not empty. Or we have to return -1. Okay, so now we try to run the code. Okay, what? Okay, so here, yeah, we have to forgot the indentation. Okay, run the code again. Okay, try to submit it. Oh my god. What's wrong? Okay. So maybe I have done something stupid here. Okay, so let me check. So here it says true, false, true, true, none. Okay, so maybe we have none. Insert get from is empty, delete from, insert carrier. Get here. Okay, so yeah, this should be only one equal sign. Okay, so run again. Okay, submit. Okay, so yeah. Okay, thanks for watching.